Let's see. I'm hoping everyone's following along, paying attention because no one has their earbuds in, right? So, class.
Yes.
Thank you. Thank you. Excited to be here. Me too. Now, we're going to go through and we're starting here at slide 9 for those people that weren't paying attention. So, before we get too far into this, I'm going to add some stuff to a slide before because once you get to your homework, you're going to have a couple other things besides this. For n, we're going to add, because these are on your notes, we're going to add some new n's. So we can have a quarterly. Anyone, what would quarterly be? How often do you think quarterly is? 4. It would just be 4. Okay? Quarterly would be 4 times a year. And next one is going to be semi-annually. Anyone take a guess? What is semi-annually? I heard it.
2.
Yes, it is 2. It's going to be 2. Okay, so we added this to our notes because some of your homework problems are going to have this. Waiting. Okay. All right, continuous compounding. Some banks use continuous compounding where compounding periods increase indefinitely. After 2 years, the balance A in account with the principal P, annual interest rate R, decimal form given by the following formula. This is the formula we've been using with the different compounding styles, monthly, annually, quarterly. That's what that one is. For continuous compounding, you're going to have this one here. So it will specifically say about continuously being compounded. A equals P, E to the RT. When you're plugging this in, you have to use the E number, not E letter. They're different. Okay? So we're going to go through and do this and calculate. No! There we go. What did I do? I did something. Anyway. So from here, there we go. You decide to invest $8,000 for 6 years, and you have a choice between 2 accounts. The first pays 2.5% per year, compounded monthly. The second pays 2.49% per year, compounded continuously. Which is the better investment? So we're going to go through and do both of these and then compare what we have. So first, I'm going to have my A equals 8,000. 1 plus my rate. For my first one, my rate is what? 2.5, but what am I going to write?
0.05.
There you go, 0.025 divided by, how often is this compounded?
Monthly.
Monthly, so that gives me what number?
12.
Very good. So 12, close, raised to the 12 times, how many years? 6 years. All right, so plug this into the calculator now, please. Your num works, hopefully. what you guys should have, and my answer is 9293 point what? 22. 9293 point. All right, 9293.22. Now, we're going to look at the next one, which is going to be compounded. I don't know how I screwed this one up. There we go. Okay. So, A equals 8,000 E raised to the 0.024 times 6. So the compounding continuously is slightly different interest rate. So that's why it's not 2.5, it's 2.49. There should be a 9 there. You keep doing that. No. 6. Now, on my calculator, gotta show you where this is. E is right below shift. Okay, that's important. So E is right below shift. 8,000 E, and there's my 0.0249 times 6. So make sure you're using the correct E. And now this one's going to be 9289.1. Because this 9 over here, the 8 makes the 9 become a 10, right?
Yeah.
So this 09 becomes 10. And it's always money. So 9289.10. Now, this is an investment. When you have an investment, you want your money to make more money, right? That's what investment is. Your money to make more money. And the better investment is your money makes the most money. So which one's going to be better? The first one or the second one? The first one is better, right? Slightly, but it is better. So when you're comparing stuff like this, those are things you have to look at. It is close, but the first one is better. What if my number, it was on there, wasn't it? And it just got weird and it's not there no more. All right, cut it off. So anyway, this one's going to be it. Now, for this next question, you'll see this. If you guys get to question 1 on the homework, and I told you guys on the first day skip it because we haven't done that type of problem yet, I'll show you how to do it after this problem here. After this problem, I'll show you how to do it. So we'll do this example, then we'll do that problem, and then we'll stop there for today. So calculating present value. So this time we're using this compound formula to find how much I need to invest to have a certain amount of money later on. How much money should you deposit, my principal, in an account that earns 6% compounded monthly, so it will accumulate $20,000 in 5 years. So I'm going to show you item by item, and this is going to be a different way to write these things out. So if you're one of those weirdos that like can't pay attention to anything, I want you to write it down like this. So P, because we have a whole bunch of different variables. We have P, we have A, we have R, we have N, we have all those there, right? And we also have T, which is my time. So if you write all these down right here, you could look and see what you're looking for. So this one we're looking for P. So A is how much?
20,000.
That's the amount of money I want to have, right? I want my account to have $20,000 in the future. R, what is my rate?
0.06.
0.06, very good. What's my N? Not 5. N is how often is compounded?
12.
12, because that one is my monthly right there. So there's my 12. T. What's T? T is time. How much time?
5 years.
5 years. Very good. So we listed everything, and now we're just going to plug it in. So we're solving for P. So I should use P equals. My formula is going to be A, which is 20,000, over parentheses 1 plus 0.06 divided by 12, close 12 times 5. Right there. So it should look just like this. So 20,000 divided by open 1 plus 5 years? Yes? So what this means is I need to deposit $14,827.44 in my account right now so that in 5 years my account will have how much? $20,000. So that's what an investment does, is makes money for you. It's increasing your money. 14,827. What's my cents on this one? 2.2? 4.4? Okay. There we go. Does that make sense? Is that pretty easy there? I hope so. Now, what I'm going to do is I'm going to help you out with the question 1. But to do that, I need a volunteer to give me their problem. Toad, are you currently working on your homework right now? Yep. So you're going to go to question 1, and you are going to help us out, all right?
That's 14.
Right next to this one here. And this is for solving for time. Alright, so while you guys are writing this down, Toad, help me out. So on his problem, what is my starting year? 16 what?
23.
So the year 1623, Anno Domino. Okay. How much money are you investing?
$36.
$36. So that means your principal, right? So your P, 36. What else did it give you? What's your rate? Okay, so my rate, 0.03. How often is this compounded? Semi-annually. So what is semi-annually? Yep, I heard it, 2. So N is 2. And my last one, what do I want to have in my account at the end? $1,000. Okay, you're starting with this year. Okay, so we're going back in time. We're going back in time to this date here. We're gonna put $36 into an account, and I want to know at what year do I jump forward to so my $36 is now $1,000. Okay, that's what we're trying to figure out. So this one, I'm giving you a formula for this to make it easier. So let's write this in. So it's going to be a log base. So it's down here, it's lower. 1 plus my rate, 0.03 over 2 close. Now, log, these are lower numbers. The log automatically opens up another parentheses right here by itself. This is not an exponent. My A value, which is 1,000, over P, my principal, which is 36, close this. And now since I'm on this line right here, I'm also need to divide all this by, what number? Two. There you go, because my N goes again. All right, ready, Toad? So this one's going to be right here, because if you're following along, we're going to use the toolbox. So start at the toolbox, and that's the log base I want to use. I want to use that because my base is not just a normal base. So I need to select that one. And now it's already put it in the base right here. Parentheses. 1 plus, what was my percent, Toad? 3?
Yeah.
Okay, so it's 0.03 divided by 2. Close. Now, if you notice, the log already opened up a parentheses for me. I didn't put that there, so don't make it into an exponent. So I'm going to arrow over to my 1,000 over, what's my 36?
Yeah.
Okay. Now I'm going over here, closing it. Now I arrow over to make sure I'm past all that. So I don't mess this up. I arrow over so I'm past all that. I hit divide one more time so it puts the whole thing over my N, which is 2. So your answer on this is it's going to take 111.64 years. That's what his is. That's how long it's going to take. But Toad's not going to put that down right now because he's paying attention. 111.64 years. But what is my starting year, Toad?
1623.
So we went back in time to 1623. We invested our money. And now we have to go forward how many years? 111.64. And I believe the thing says round up, right?
Yeah.
So we would round it. So it'd be 112 plus 1623. So my answer should be 1735. So in the year 1735 is when my account finally reached $1,000. Is that, yeah.
Yeah.
Okay, there you go. You guys all like, share, and subscribe. Hit that notification button. Support my channel. If you wrote all this down, all you have to do is change out yours for your numbers.
I need some water.
Yeah.